Hello students, here in this video we are going to discuss about how to implement Boolean functions using multiplexers. Here you just look the logic diagram of a 2 to 1 multiplexer. The logic diagram of a 2 to 1 multiplexer consisting of two data inputs and one output. To select one of these two data inputs, it requires to have one select input. If the select input is 0, it is going to select the data 0. D0 is going to be selected. If the select input is 1, it is going to select data input 1. How it is going to be selected? Because when select input is 0, the input to the first AND gate becomes 1, right? This is 1 and data input is 0. 1 and data 0 is called D0 is going to be selected, and other input to this second AND gate is going to be 0, so that if any one of the input of AND gate is 0, this is 0. So what is going to be selected? D0. Suppose if the select input is 1, then this input is 0, output of this AND gate is 0, this input is 1, the output of this AND gate is data 1, and what is going to be selected? Data 1 is going to be selected, means selecting one of the data inputs and redirecting to the output. So here you observe, because it is an internal logic diagram of a multiplexer, it is having AND gates and OR gates, and each AND gate is representing one minterm, and these minterms are summed to get the required function. It means a multiplexer is representing a Boolean function which is in sum of the product forms. It means if any Boolean function which is mentioned in SOP form can be easily be implemented using a multiplexers. Here, for the sake of your notes, it is mentioned clearly. A multiplexer consists of AND gates whose outputs are connected to single OR gate. Because of this construction of any Boolean function in SOP form can be realized using multiplexers. Here, how will you get a questions? This is one of the question. And what is this question says? Implement the following Boolean function using multiplexers. What is the function f of xyz equals sigma 0 to 67 given? 0 to 67 are minterms. So that to implement this Boolean function using multiplexers, because this function is having three variables, with three variable, how many minterm combinations are possible? 2 power 3, 8 combinations are possible. It means to implement this Boolean function, we requires to have 8 by 1 multiplexer. In this 8 by 1 multiplexer, these function variables x, y, z is to be connected as select inputs to the multiplexer. X, Y, Z are connected as select input to the multiplexer. So that these select inputs are going to select one of the data inputs and redirecting to the output that is representing the function. Now it is a simple logic. If the select input is 0, the function output should be 1. Similarly, if the select input is 2, 6, 7, the function output should be 1. So means when the multiplexer inputs are 0, 2, 6 and 7, the output of this multiplexer should be 1, so that this is to be connected with a logic 1. And look at for other inputs. For other inputs means for other minterms, the value of the function should be 0, right? So means these other minterms are to be connected with the logic value 0. This is to be connected with logic value 0. This is equals to 0. Right. This is a simple implementation of Boolean function using multiplexers. Here, for the sake of your notes, I have mentioned the points very clearly. Each AND gate in a multiplexer represents a minterm. By connecting the function variables directly to the select inputs, so here x, y, z are the function variables directly connected to the select inputs, a multiplexer can be made to select the AND gates that corresponds to the minterm in the function. If a minterm exists in a function, we have to connect the AND gate data input to logic 1. Otherwise, we must connect it to logic 0. This is a simple realization of a Boolean function using multiplexer. Here we will look another question. Implement the following Boolean function using 4:1 multiplexer. Now, what is a Boolean function? F of ABC equal to sigma 0 to 56. Now, how many variables are there in the function? Three variables. Three variables means how many minterms are possible? 2 power 3. 8 minterms are possible. 8 minterms are possible means it can be implemented using 8:1 multiplexer. But what is asked? 4:1 multiplexer. Because it is asked to implement using 4:1 multiplexer, it is having 4 data inputs and 1 data outputs, that is to represent the function. Because only 4 data inputs, but function is having 8 data inputs, means 8 minterms are possible. So that to implement this one, we have to connect the two least significant function variables as the select inputs. So what are the two least significant function variable? B and C need to be connected as input to the select variables, right? And now the data input 0, 1, 2, 3 is to be determined with respect to A. That is by using a function table, or we call implementation table. Look at the first step is connect two least significant variables B comma C as a select inputs of multiplexer. We have connected and derive the inputs for multiplexer 0, 1, 2, 3 with respect to A using a special type of table called implementation table. Now, this implementation table consisting of 8 cells. Because I am going to implement using 4:1 multiplexers, there are 8 cells and 8 cells are divided into 4 cells and 4 cells. Means this is a cell representing 0, this is a cell representing 1, and this is a cell representing 0, 0, 0, 1, 1, 0, 1, 1. Means when you look for the 3-bit combinations, when you look for the 3-bit combinations, 0, 0, 0, 0, this is representing minterm 0. So because minterm 0 is function variable, means as part of the function, so represent it with 1, right? Similarly, 2, 5, 6 are there. So for better understanding, what I'm trying to do is, I'm trying to represent the number for the minterm. This is a minterm 0, it is 1, this is 2, this is 3. Why? Because 0, 1, is 3. 1, 0, is 4, 1, 0, 1 is 5, 1, 1, 0 is 6, 1, 1, 1 is 7. And do remember, it is not a K-map, it is called implementation table. Now here in this implementation table, this is for data input 0, this is for data input 1, this is for data input 2, this is for data input 3 of the multiplexers. Now here, look at this row is representing A and A dash. A and A dash. Here the first row, the value of A is 0 and these two are BCs. The first row value of A is 0 means A is complemented. The second row, the value of A is 1 means A is uncomplemented. Now, the next thing is we have to circle those minterms which are part of the function. 0 is part of the function. 2, 5 and 6 are part of the function. Now here the data inputs D0 input, D1 input, D2 input, D3 input we are determining with respect to A. Look at here in the last column, no minterm is selected. Because no minterm is selected means minterm 3 function value should be 0, minterm 7 also function value will be 0. Means if no minterm is circled, it is represented with 0. Means data input 3 is to be connected with 0. Now data input 2, look at both the minterms under data input 2 are circled. Means for minterm 2 the function value is 1, for minterm 2 function value is 1, and for minterm 6 also function value is 1. Means data input 2 should be connected with logic 1. For data input 1, only 5 is circled, not the 1. 5 is under which row? A row. So means data input A, data input D1 should be A. This is A. Now what happened with D0? only 0 is circled but not 1. Now 0 is represented by the row A dash. So data input 1 should be A dash. Now this is a realization of Boolean function f of ABC equals sigma 0256 using 4 by 1 multiplexer. It is very simple. Okay, we will understand one more question. Look at the question. Implement the following Boolean function using 8 by 1 multiplexer. 8 by 1 multiplexer. Look, what is a function? Now function is f of a, b, c, d. 4 variables. There are 4 variables means how many minterms are possible? 2 power 4, which is equals to 16 minterms. 16 minterms means this is going to be implemented using 16:1 multiplexer. But it is asked you to implement using 8:1 multiplexer. Because it is to be implemented using 8:1 multiplexer, look at what 8:1 multiplexer is having. 8 data inputs and should be connected to the output function variable, right? Here, to have 8 data inputs, always we have to consider the 3 least significant digits to be connected as inputs to the select inputs, because 8 data inputs are possible. So how many selection lines should be there? 3 selection lines. The 3 selection lines will be the select inputs B, C, D, and these are the least significant bits of the function. Now, the data inputs are to be determined with respect to A. So what will be the data inputs that you have to determine based on the implementation table? Now here the implementation table should have 2 rows. Each row will have 8 cells. Why? Because here the data inputs of multiplexer to be determined using only A. So this is 0, this is 1. So it is meaning that it is A dash, this is A. Now what are the data inputs? Data inputs are 0 to 7. Because data inputs are 0 to 7, we can call data input 0, 1, 2, 3, 4, 5, 6, and 7. Now here what are the minterms? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Now it requires to circle the minterms. Which minterms to be circled? 0, minterms that are part of the function, 0, 2, 3, 6, 8, 10, 11, 12, 13, and 14, right? So these are the connected, right? 0, 2, 3, 6, 8, 10, 11, 12, 13, 14 are circled. Now derive the data inputs. Here both the data inputs 0 and 8 are circled, means it is representing the logic one. And 1 and 9 are not circled, it is represented with logic 0. 2 and 10 are circled, it is represented with logic 1. 3 and 11 are circled, it is represented with logic 1. Only 12 is circled, 12 is under A row, so data 4 input will be A. And here 13 is circled, that is 13 is under A, so it is 1. And 6 and 14 both are circled, it is 1. 7 and 15 not circled, it is 0, right? This is 0. These are the data input 0. Now connect 0 A dash. Look, data 0, D0 is 1, D3 is also 1, and D6 is also 1, D2 also 1, D2, D6. These are all 1. So simply what we can do is these are all are connected with logic equal to 1, because 1, 2, 3, 6 data inputs are 1. And look, 0 is there for data input 1 and data input 7. For these two data inputs, 0 is there. So connect these two data inputs to logic equal to 0. And A is there for which data inputs? 4 and 5. For 4 and 5, A is there as the data inputs. So A is there as the data inputs to 4 and 5. So all data inputs are connected. And you know that multiplexer will have enable input to enable or disable the multiplexer. Now this is a design of this Boolean function using 8 by 1 multiplexer. Hope you understood. Check for one more question. Implement the following Boolean function using 4:1 multiplexer. Now, here what is a Boolean function given? A, B, C, D. Means how many variables? 4 variables. Means how many minterms possible? 2 power 4 equals 16. It means this is going to be implemented using 16:1 multiplexer. But it is asked to implement using 4:1. Previously, we have discussed the same implementation using 8:1. How 8:1? We have discussed the 3 least significant digits of the function are connected with the select inputs, and the data inputs of multiplexer we determined using A. Now here what is asked? The question is to be implemented using 4:1. Now look at, we have a 4:1 multiplexer. Because 4:1 multiplexer is there, how many data inputs are there? 4 data inputs. Because 4 data inputs are there, how many select lines should be there? 2. And the 2 select lines should connect the 2 least significant function variables. What are the 2 least significant function variables? C and D are connected as the select inputs of the function. It is to be connected as select inputs of the function. Now C and D. Now this data input 0, 1, 2, 3 is to be determined using the higher significant digits, that is A and B. Now how to do this? This is to be done by having an implementation table. Because I am using 4 by 1 multiplexer, totally 16 minterms are there. Now I have to have an implementation table which is a 4 by 4 matrix. Means each row is representing 4 minterms. Now look at, this is minterm 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now these are the data input 0, 1, 2 and 3. Now what will be the row values? The row values, the first row will be 0, 0, 0, 1, 1, 0, 1, 1. Now these will be determined with respect to the higher significant variables in the function A and B. It means this is A dash B dash, this is A dash B, this is A B dash, this is A B, right? These are the possible values for the each row, right? Now first circle it, the minterms that are part of this function: 1, 4, 6, 7, 8, 9, 10, 11, 15. 1, 4, 6, 7, 8, 9, 10, 11 and 15. Now based on the minterms that you have circled, you can determine what are the data inputs. Now data input 0. Data input 0 should be the minterms 4 and 8, and minterm 4 is represented with respect to AB inputs are A dash B plus AB dash. A dash B plus AB dash is called A exclusive or B. So means data input 0 should be A exclusive or B. This is XOR function. So we have two data inputs A and B. Okay. Now look for the second one, data input 1, which is circled 1 and 9. 1 is representing A dash B dash, 9 is representing A B dash. So if A dash B dash plus A B dash, if I take a B dash common, So a dash plus a, that is going to be 1. So the simplification of this d1 input is b dash. So what is connected to data input 1? Only b dash is connected. Now look for the data input 2. Data input 2 which are connected, which are circled 6 and 10. 6 and 10 is representing a dash b plus ab dash. This is representing a exclusive or b. So what is recommended is this exclusive or same thing is connected to the data input 2 of this multiplexer. So multiplexer data input is connected with it. And the last one. And the last one you look at, this is data input 3 is function of 7, 11, 15 minterm. 7 is now a dash b plus 11 is ab dash plus 15 is ab. Suppose if I take a common of these two, what I am going to get a dash b plus a. Now a plus a dash b is same as a plus b according to theorem, a plus b. Now what is the data input 3? Data input 3 should be a plus b. This is the OR gate, and the data inputs for 3 is ab, a plus b. Now this is realization of Boolean function using 4:1 multiplexer. Here look at this is take it as a work and try to solve this question. Hope you have understood the realization of Boolean functions using multiplexers. Thank you.